look at two different compound inequality statements and see what the answers, if we simplify them, would be. The first one is going to be an AND statement, so I'm going to talk about all of the numbers x's such that they are greater than 9 and the numbers that are less than 5. What numbers would this be? Well, let's look at a number line, because it does help us to see these things visually. Well, and we have the two numbers 5 and 9. And I'm interested in this first one here on the left. X is the numbers that are greater than 9. Since they're greater than, we just have an open circle. And all of the numbers that are greater than that. Then the one on the right, we have X at all the numbers that are less than 5, not equal to. So once again, an open circle. And all the numbers here. Remember that an AND statement says, I want to know what numbers are true for both of these statements. Any number I pick over here, say the number 10, will only be true for one of these statements, not both of them. So when I ask for what numbers are greater than 9 and less than 5, the answer is no solution, because you have to tell me that there aren't any numbers that are both greater than 9 and less than 5 at the same time. Now let's look at another statement. What if I said x is all the numbers that are greater than or equal to 4, or all the numbers that are less than 10? Graphically, we have the numbers 4 and 10. If we're looking at the statement on the left, we can see that it can equal 4, so we have a filled-in circle. And all the numbers that are greater than 4. And remember, they go on forever to towards positive infinity. The statement on the right, all the numbers that are less than 10, implies not 10, but everything below that. So I'm interested in what numbers are true for at least one of these at any given time. Let's pick a few numbers. If I had the number, say, -3 right here, I could see that that is true for, I can find a spot on that number line right there, that it is true for one of these statements. Let's pick a number way far over on the right. How about a number here? Say the lucky number 13. Well, once again, I can see that it does exist for at least one of these statements. So that would be true. So everything on the right of 10 is true. What about any number between 4 and 10? Well, let's just pick a number we can see. Whoops. Sorry about that. I lost one of my arrows. Let's pick a number that's somewhere between 4 and 10. Well, let's pick a number right here. How about number 8? Number 8 is true for both of these statements. And then there's the tricky number 10. If I pick actually 10, I can see that it's not true for one of the statements, but it is still true for this statement, all the numbers that are greater than or equal to 4. Well, this is strange. Anything that I pick on the left of 4 worked, anything I picked on the right of 10 worked, anything that I picked between 4 and 10 worked. We know that at 4 it works, and we just talked about that at 10 it works. In fact, it looks like every number that I pick that's on the number line, any number on the number line works. Well, how can I say any number on the number line? Any number on the number line means any real number. And so the answer for this is all real numbers work. Any number that you can pick that would be on a number line is true for this OR statement.